So, in a human breast, basically it consists of the fatty tissues. The fatty tissues are visible in a grayscale in this mammogram, and it also includes the glands. We call it as the fibroglandular tissues. They, due to the attenuation of the X-rays, they are going to appear brighter on the mammogram. For instance, here in this picture, you can see the white pixels. These are the glandular tissues. So, according to when you go for a mammogram assessment or the screening assessment, the radiologist will give a report about the density of your breast, whether you have the higher density breast or low density breast. So that depends upon the amount of the relative amount of fibroglandular tissues that are going to present in your mammogram. So it's like if there is if the women are having the highest breast density, they are having more chances of getting the cancer in the future, and the women with the less density are going to have the less sensitivity for this, or it's like more sensitivity for getting rid of the cancer cells. And you can see here most of the cancer tissues are going to reside inside the fibroglandular tissues, and the cancer cells are also going to be appear brighter on the mammogram. So when we go for this screening assessment, the radiologists have it's a great challenge for the radiologists to get to identify what is the fibroglandular tissues and where the cancer cells are residing, because it's just looking like a snowball in a like we are trying to find this snowman in a dense snow cloud. We, the researchers from the University of Eastern Finland and collaboration with the Kuopio University Hospital, we are interested in working the breast density assessment. So usually the mammograms are used for the breast screening purpose in order to estimate the breast density. So for instance, if you see in this picture, we have 4 different categories of mammogram. So the first picture is like the very less dense breast. So it means like the human breast is composed of both fatty tissues and the glandular tissues, and due to the attenuation of the X-rays, these glandular tissues will be visible white in the mammogram. For instance, these white pixels are the glandular tissues and the gray color pixels are the fatty tissues. So if these glandular tissues are more, then it's considered to be a dense breast, and if these fatty tissues are overcoming, then it is called as the non-dense breast, or we can even call it as a fatty breast. So here, when it comes to the cancer risk, due to the more attenuation of the X-rays, this particular dense breast is going to hide the cancer tissues. So it means like we need to have the extra screening process, or maybe the other biopsies should be invented for this. Basically, in this research, we are trying to segment the glands from the mammogram in order to investigate more like how the cancer cells are trying to develop. So in this architecture, we are developing the unit architecture, where the main objective of this network is to segment these fibroglandular tissues from the mammogram, and then we try to estimate the percentage of the density. And it is significant that the people or the women who are going to have around like the higher dense are going to have a risk of the cancer. And we develop a new algorithm that is trying to identify the fibroglandular tissues more accurately, so that can help the radiologist for the further assessments. This particular overlying image, the algorithm we are developed using the artificial intelligence, is trying to predict the fibroglandular tissues from the original mammogram.